I'm Neil Woodard for Kit Guru. We used the MSI MEG Z490 Ace motherboard in our launch review of the Intel Core i9-10900K Comet Lake S CPU. We showed you this motherboard running, did a BIOS update, showed thermal velocity boost, did some overclocking, did all sorts of stuff. Didn't discuss VRM temperatures, but we have shown you the motherboard. Nonetheless, we haven't done a review of the motherboard, and that's what we're doing today. It's an ATX design. This shielding is all metal. This is plastic. On the back, we have a partial backplate that's also aluminium, and these little heat spreaders go over the doublers. On the I/O panel, we have a clear CMOS button, a flash BIOS button, an old school PS2, which should please the overclockers, a pair of USB 2s. We've then got two USB 3.1 Gen 1s, four USB 3.2 Gen 2s, including a Type-C, connections for Wi-Fi 6, and a pair of Ethernets. The Ethernets are unusual because it is Realtek 2.5 gigabit and Intel gigabit. The main features: we've got dual graphics slots. The Z490 chipset allows them to split the PCI Express Gen 3. Remember, we're still on Gen 3 to 8 and 8, so you can have Crossfire or SLI, unlikely. And you have a third full-length PCI Express slot plus a couple of ×1s. M.2s, we've got two 80s and a 110. Four DDR4 slots that support memory up to 4800 megahertz when you overclock, and also capacity of 128 gigabytes in 4 DIMMs. We've got a pair of 8-pin EPS connectors there, 24-pin on the side, as you can see. Headers and connectors for fans in particular, we've got loads. We've got fan connectors here and also here and at the foot of the board. No problems there whatsoever. We have support for digital RGB. We've also got a full complement of USB headers and also laid down SATA connectors on the side of the board. At the foot of the board, we've got overclockers features, so a debug display and micro buttons. All good to see. It's also worth noting that while the Comet Lake S processor supports Gen 3 PCI Express, MSI tells us this hardware here makes it Gen 4 ready, which is clearly a nod to the next gen Alder Lake S. Removing the heat sinks, shields and other bits of furniture reveals the 6-layer PCB and the Intersil ISL 69269 VRM controller. The 16 VRM phases for the V-Core and 1 for the SoC are all 90 amp stages. Naturally, MSI's used doublers to achieve that huge number. You'll have noted there are no graphics outputs on the I/O panel, so that powers almost entirely for the processor itself. For our test setup, we're using a Streacon Mini Open Test Bench, processor Intel Core i9-10900K, CPU cooler Fractal Design Celsius S36 with 3 Noctua Chromax NF F12 fans, memory 32 gigabytes Corsair Vengeance LPX 3600, 16/18/1836 timings, graphics Gigabyte RTX 2080 Super, SSD 1TB WD Blue M.2 NVMe. Power supply is a mighty Seasonic Prime Platinum 1300 watt. Since we finished the CPU launch review and I've returned to the MEG Ace, the BIOS has been updated to version 1.16. However, superficially it looks exactly the same as 1.13. Let me just load defaults so you can be absolutely sure there's no shady business going on. Re-enable XMP. That's the only thing I'm going to do. If we now go down to overclocking settings, advanced CPU configuration, TVB ratio clipping, that's thermal velocity boost ratio clipping. It's set to auto. The options are auto, disabled, enabled. I'm going to leave it on auto. Come out of there. There are some extra settings that have appeared in the BIOS compared to the previous versions. These are apparently for LN2. We can ignore those. And if we go across to hardware monitor, you will see we've got a load of temperatures reported, including VRMs, 37 Celsius at the moment. I've also hooked up some thermocouples to the VRMs themselves. Obviously, they're outside the chips. They're clamped between the heatsink and the chip, so that's the exterior of the chips. It's a 35 Celsius a piece in round money, and here we have 37. So at the moment the temperatures look absolutely fine. Obviously I've pulled off a load of the shielding so you can actually see what's going on. And there we have the active cooler. If I now hit F for all the fans to go to full speed, have a listen. (12,000 RPM). So that fan draws air in through those holes there above the USB. Just those there, draws air in and then blows it across the cooler. The idea that up to 12,000 RPM fan is going to draw a useful amount of air through there, well, that's a question, isn't it? Anywho, that's what's going on the BIOS. So we do have full temperature reporting going on. Within HW info, we see the reported voltage for each core. However, that's VID rather than V core, so it's not necessarily correct. We've got clock speeds in the usual way, bus speed. Moving on down to details about the processor, we've got the temperature of the CPU package. We've got the power that it's drawing. We do not have anything called V core. Further down, we have the MSI MEG Z490 Ace. That there, T15, I am told by MSI is the VRM temp. Not that you'd know that from this software, which is frustrating. If I turn on my thermocouples, and you will see at the moment T15 is 39.5, that's within the chips on my meter, 36.6, 36.7 and 37, so we're 2 to 3 degrees below. So that looks plausible, but how on earth you'd know about T15? Well, that's a different question. Let us open Blender, and we've got an all-core speed of 4.9 gigahertz, exactly as we would expect, and exactly what I showed you in the review of the i9-10900K. So 4.9 all cores. All the cores are in the mid to high 60s. CPU package is 69, now 70. Thermal velocity boost, as we know, cuts in at 70. The fans are set low and slow, so the temperature will climb higher than you saw in the CPU review. Package is now reported at 71. Some of the cores are now over 70, one or two are below 70, in fact about half and half. Package 72. The clock speed is still 4.9 all cores. No breaking ranks, we haven't got any 4.9, 4.8, it's all 4.9. Package now 75, 76. All the cores are 70 or above. And the speed is a rock solid 4.9 gigahertz all cores, which proves the point. Thermal velocity boost has been disabled in this version of the BIOS by default. But you cannot tell that anywhere. You have to actually know what you're looking at in the BIOS to work that one out. Slightly confusing. Good performance, but confusing. So what are the VRMs doing? Bearing in mind we're on a basic clock speeds 4.9, we're looking at 42, 44 Celsius. The little cooling fan hasn't yet started to spin up, but we wouldn't know the VRM temperature from HW info, would we? Because it doesn't report it anywhere. If we open MSI's Dragon Center software, and here we see that the VRMs, according to the software, 54 degrees. Now, it might be true inside the chips, my meter's saying 43 and 46, so there's obviously going to be a bit of a differential, but they're saying 54. Also worth noting that CPU core voltage 1.25 in round terms. So the figure that is reported here, 1.306, 1.305, is, as we'd expect, higher than the actual V-core, but that V-core does not appear in HW info. And we can see that the VRM temperature is slowly climbing, but it's not doing anything too outrageous at the moment as Blender continues to run. At a rock solid 4.9 gigahertz, it seems clear we're going to need to overclock the CPU in order to feed more power to the system so we can push the VRMs harder and check out what the cooling is actually doing. Pushing the VRMs harder, 5.1 gigahertz all cores. According to Dragon Center, the VRM temp is 64. According to my measuring, 54 and 55. The fan has not yet started to turn. CPU temp meanwhile 84 degrees Celsius and the socket 64. So the CPU is working quite hard, the VRMs not really. Heatsink just under 50. Fans just starting to kick in, 66 on the software, I'm seeing 56. There we go, just coming into action. It's not until the VRMs are 70 degrees that the fan is constantly spinning rather than stop-start. According to my meter, the exterior of the VRMs 59 and now 62. The VRM fan is completely inaudible. It's the cooling fans on the radiator making all the noise. That fan is barely spinning. We've learned a number of things from that bit of experimentation. In the first instance, it appeared that MSI wasn't reporting the data we required for VCore and for VRM temperatures. In actual fact, the data is being reported. It's just the software doesn't necessarily know what to do with it. The idea that MSI doesn't talk to HW Info on an almost daily basis, particularly a new platform, strikes me as just extraordinary. However, if you don't want to use HW Info, or if you're prepared to use Dragon Center in addition to HW Info, you're good. I'm going to point out something about Dragon Center, which is that you cannot resize the interface. If you want to put the software on your monitor, that's the size it is, which is just extraordinary. Furthermore, it is clear that the VRMs are operating at a perfectly decent temperature, which is what we'd expect from so many 90 amp stages. The coolers on the VRMs, they don't look like the best. Ideally, they'd be fully finned affairs, but they're not. They're kind of slightly profiled aluminium blocks. The tiny active cooler seems to me to be entirely unnecessary. It's clearly there as a backup. But in the event the VRM coolers were perfectly decent in the first place, the fan would be just unnecessary. So that strikes me as a moderately poor choice by MSI. The fact the MSI MEG Z490 Ace is so expensive at £400, that says to me MSI has no excuse for making poor decisions. Everything at a board of this price should be close to perfect. The VRMs, yup, they look top notch. The coolers on top of the VRMs, not so good. So instead of fixing the coolers, they stuck on the active fan. Having said that, unless you're absolutely slaughtering the platform, the VRMs are not going to get hot. You should not expect to hear that fan in operation. The other thing is, it is crystal clear that the BIOS version affects the way the board operates to a huge extent. When I updated from version 1.12 to 1.13 to make thermal velocity boost work correctly, as you saw, it just made the 5.3 gigahertz feature just flick into life on occasion, so work in inverted commas. That was down to the BIOS and power limits. And then ironically, MSI updated to version 1.16 and totally changed the behavior of TVB. So it is down to the BIOS version rather than the board itself, how it behaves. In fact, most of what you see with how this board operates is down to the BIOS. So the board is one thing, the BIOS, that's a whole different kettle of fish. We're going to look at performance charts, but before we do that, let's take a look at the Shimano tool, which shows how MSI is treating power delivery for the Core i9-10900K. And in essence, it's feeding all the juice to the processor that the processor can use. PL1, PL2, tau, MSI is ignoring all that good advice from Intel. The consequence is this processor is taking a lot of power. And you can see the consequence in our power at the wall socket chart, as on auto, the CPU draws 225 watts and the system draws just about 300 watts. The thing is that 225 watts is powering at 4.9 gigahertz auto all cores, but it will stick at 4.9 gigahertz all day long. It won't pull back after 28 seconds or 56 seconds. It will sit there forever. If you overclock to 5.2 gigahertz all cores, that'll take another 60 watts, so 286 watts for the CPU, and now 375 watts for the system. That load doesn't include graphics, we're talking processor and system. The knock on to the VRMs is clear. At 4.9 gigahertz auto, the VRMs actually run really cool, but we've seen that the VRMs are a mighty piece of engineering. Overclocked to 5.2 gigahertz, the VRMs get slightly warmer. They're still well shy of danger territory, and you've seen there's an active cooler on the VRMs. However, that power, it does have consequences. It turns into heat. Nonetheless, you've got plenty of headroom. In a straightforward CPU test such as Cinebench R20, the MEG Z490 Ace does well. It does well out of the box because it will power at 4.9 gigahertz through the entire test without pulling back. And when you overclock, it does even better because, you know, it's a CPU test. It's a slightly more nuanced result when you look at 3D Mark. We're looking here at the physics and CPU tests in 3D Mark and Ultra and Time Spy, but the MEG Z490 Ace does well. Clearly these are results that are indicative of how the CPU is going to behave in games, and it's perfectly acceptable. As a final test, we ran Crystal Disk Mark 7 using a Sabrent Rocket M.2 SSD in each of the 3 M.2 slots. Performance is good and consistent, but of course this is a Gen 4 SSD in a Gen 3 motherboard. AMD will offer you more bandwidth, no argument there. In conclusion, I'm glad we used the MSI MEG Z490 Ace to review the Core i9-10900K because it did a decent job. It ran that CPU to the limits. It showed what Intel has done with the new silicon. The motherboard itself is a solid piece of engineering. The VRM's good, they do a proper job. The armor over the rest of the board, covering the M.2s, the VRM heat sinks and so on and so forth, perfectly decent. I'd say it's more about aesthetics than function. I'm not mad keen on the heat sinks themselves. I wish they were more heavily finned rather than being slabs of aluminium. If that was the case, I think we could do without the active cooling fan. But generally speaking, it's successful. The chest plate on the back, which doesn't come anywhere near the VRMs and the doublers, I think is indicative of how MSI has approached the design of this board, which is you can't argue with the looks of it. However, in terms of function, that is doing not a huge amount. I cannot point at this motherboard and show you anything that is missing. In terms of features, it's got absolutely everything, which is quite impressive for an ATX board. That's normally the sort of thing you say about an eATX. This ATX board, it's not hugely overcrowded, but it's got absolutely everything that you could want. And you might easily make the case that as you're not going to run dual graphics cards, in fact, it's got, in a sense, too much. Access to the M.2s is pretty good. The I/O panel works. Everything is in the correct place. Arguments? None, actually. The biggest single problem I've got with the MEG Z490 Ace is pricing, and I'm laying that at Intel's door, because MSI presumably has had to pay some sort of premium for the Z490 chipset. That's pure guesswork, but it's new, it's from Intel, therefore you assume it's not going to be cheap. But they've absolutely definitely had to step it up with the VRMs, and that must have cost them money. The takeaway is that £400 for a decent, fully featured motherboard without anything, there's no OLEDs, for example. They haven't taken it to the next level like godlike. So it's got a load of features, everything must have cost money, but £400 still feels expensive. It looks like £400 is the new normal, where you'd like to think 300, maybe even 250. 400, unfortunately, I think it's where it's going to be at for motherboards that can support the 10-core Core i9-10900K. I'm not best pleased about that. I think I just have to accept the inevitable. So MSI has done decent work. As discussed at length, they could certainly help out if their sensors were to report to software such as HWinfo64, so we can keep an easy eye on VRM temperature and vCore without having to resort to using Dragon Center software. But we are in the realms of a tweak to the BIOS here, a word with HWinfo there, and the board would be better. And they wouldn't have to actually change anything on the board itself. So there is still room for improvement. I think they can make that improvement quite easily. However, the pricing, I suspect, is going to remain the same, unfortunately. If you like this video, give it a thumbs up. Head over to kitguru.net to read our news and reviews. Head over to the merch store to buy a t-shirt. I'm Neil Wood for Kit Guru. This is the MSI MEG Z490 Ace.